So now students will see how a bottom-up PDA works. Okay. For the last class, we checked a top-down PDA, and this is a bottom-up PDA. Now, for top-down PDA, you'll remember you're used to that symbol or tag and replace it with the productions on the right-hand side. Okay. So now in bottom-up PDA, okay, we will be using the productions, okay, and then we will be replacing it by A. So alpha will be replaced by A. So here now in bottom up, you can see that the tree is extended upwards, and in top down, the tree is extended downwards. In top down PDA, we saw that the process terminated when the stack was empty. That is, Z0 was only present on the stack. Now here, the process should terminate only when the start symbol is left onto the stack, because this is a bottom-up PDA. Here we have a grammar, and we have used rightmost derivation to derive a string. So let me explain to you all. I have numbered these productions S plus T. Okay. From S plus T, I will be replacing T. So that is, I'm using the third production. From that, I will be using the fourth production to replace this T by A. Then the second production to replace this S by T. So I have derived a regular expression like A plus A into A. So this is a grammar to derive some regular expressions. You'll have seen by using a rightmost derivation how I have derived this A plus A into A. Now, this works in opposite way compared to the top-down PDA. Initially, now here the stack top is Z0. We are taking the input with us, that's the leaves of the tree. A plus A into A. And if you'll see this table, it ends up in the start symbol S. So S is left onto the stack. That means the string has been accepted. Let's check out how this bottom-up PDA works for this particular expression. So A plus A into A. The stack top is Z0. So now here we will be shifting this A, which is present over here, onto the stack. So this operation is called shift. You mainly have two operations in bottom-up PDA, shift and reduce. So this is shift because you're moving it from the input encountered onto the stack. So we are left with plus A into A. Okay. So A, Z0 are the contents of the stack. I have to approach S. So I have to replace this A, small a, that's a terminal, by T. Okay. How can we do that? You see this production number 4. So T in place of A, I will be writing T. That is what was said over here. That is in place of alpha, you're writing capital A. That is what is there on the left hand side. So instead of A, I will be writing T. So here you can write what productions you're making use of. This is a column for that. So in place of A, I have written T. Okay, this is the input which is copied from the previous row. Now this S, I can use a replacement T, S giving T. Let's go and check here. Okay. S giving T, that's the second production. So here you write it this way, S giving T. So this T is replaced by S. So after replacing this S, you have to push this plus sign onto the stack, which is called as a shift operation. After pushing the plus, you cannot use more productions. Okay. So then you also shift A. So I have on the stack A plus S. Now this A, you again use reduce operation, replace this A by T. So you have T plus S. T plus S, you already converted into non-terminals. Next, you just reduce, okay? You shift star onto the stack. So I have written a shift operation here. Again, A onto the stack. I have used a shift operation here. Now, if you see, there's an operation T into A giving T. That's the third operation. Okay, so T into A giving T, this gets reduced to T. Okay, so T plus S here. See, here it is S plus T. So they were moving backward. So you have to write T plus S. So be careful about that. Here it is. And then you finally write the start symbol. That means this, the production S giving S plus T. So you write S. So from here you see that it has already led to a start terminal. Then you can pop the element out from the stack, leaving Z0 onto the stack and saying that the input has been accepted. Okay, so this is your bottom-up PDA. Thank you.